OK, auto-poking the bear. Oh, yeah.
All right, so we pulled the audible. We're going to be first up after lunch, which is the witching hour, so we'll try and keep this light and entertaining. I am Brad Palm. I am the COO at Dreadnode. And don't be discouraged by that dreadful title. We are encouraged to stay hands-on, engage in research at Dreadnode. Luckily, we get to do that together. But I was trying to come up with a better title to be next to yours, and I was thinking maybe continuously out of office. You know, chasing adventures might be a good one for the acronym of COO. But extremely honored to share the stage with this esteemed colleague to my left.
Well, my name is Martin, and they did not make a PowerPoint box big enough for my last name, so that's actually a hack that you see there right now. I'm an AI research scientist at Dreadnode and also a PhD researcher.
Distinguished gentlemen.
Agenda. Well, we'll start by looking at how CTI has evolved as a discipline and what we need to be looking at next to maintain our trusted circle and in order to maintain this sort of high-level analytical tradecraft that we've all grown accustomed to in what I call an inherited problem, which is coincidentally also what my family calls me. Then Brad will walk us through Vibant, the new age of agentic Intel analysis and why we should be talking about data provenance of finished Intel products. By the way, if we want to start the clock, he will continue leading us into our applied part of this talk, which is hunting certain Russian spies in older data sets with an agentic workflow. I'm afraid I can do that, Dimitri. Then we'll talk about how to make those rudimentary agents better, how to gather telemetry on them, and the target metrics by which we judge performance in performance improvement plan. And we'll finish out by looking at a specific piece of intel, which is this guy Sergey at GRU really likes McDonald's, and what we should disclose about the agentic analysis system that gave us that piece of intel, and how we hopefully will have a convention in the future in order to communicate the trade-offs we make in designing something like that. OK, so he's not here because of technical issues with his slides. And that's fine, because I knew otherwise he'd blush and be uncomfortable. But I actually cannot recommend enough that a talk that Jags did in 2019 about CTI as a developing field. In it, he laid out 3 big problems, which back then were we chased the media a lot. Because in many orgs at the time, CTI was basically glorified marketing. So media presence is what counted. Then we don't communicate open questions enough because certainty is rewarded, both in the public phase and within our orgs. And we don't look backwards enough through old telemetry. That's a point he actually illustrated very, very nicely by looking through old telemetry, hunting for a known APT, and finding 3 more intrusions within just seconds of effort. And I think as a community, we've made headway on all 3 of those. So we've actually partially become the media. You know, everybody who listens to the 3-Buddy podcast, basically there's a forum now where threat and intel gets judged by threat intel analysts. And so we don't chase Kim Zetter around as much as we used to. We, I think, have gotten a lot better at communicating open questions. Just in public, yes, but also in the sort of trust forums that make up this space. And I think the last one is sort of still open, but we're being saved by the bell, by the sort of technological progress, where we can now look back further and with more frequency by basically leveraging more advanced systems to do that. The question is sort of how often do you look at data sources that are not part of your investigation, right? We all look at telemetry from endpoint detection, but my point is I want us to be at the bottom of the stack. I want us to be like in Sergey's McDonald's orders, to really understand our opponents on like a target-centric granular level in order to make their lives that much more uncomfortable. But the problem with any new technology is, right, we're rolling this out, we're doing this, but since it's a new technology, our approach also needs to change. And that's really important because Intel is a pipeline. So any sort of pollution that we do upstream, where we may be using a technology without clearly communicating its upside and downsides, will have negative downstream effects. And finally, why are we talking about Russia? Nah, right, that's a fair question. I mean, this seems like a theoretical talk. Why are we doing applied stuff at all? And I can already see some eyes glazing over, right? This theoretical talk. I sort of lost awareness that my life is not a meme. And if some of you that were here will recall my 2023 talk on Russian influence operations laundered through Hungary. After that, both the Hungarian and Russian governments complained, and then they continued their doxing attempts against me and Ben Novak, the researcher I was working with at the time. So this is also just about Dreadnode hiring a researcher with a grudge.
You stayed on point with timing. Well done.
Yeah,
that was solid. All right, so Martin's my inherited problem. I have to figure out what to do with him, and he has very strong vibes. So imagine for a moment, right? We're entering this new era, and Vibant is this new collection process that is going to rule them all, right? Humans out the door, SIGINT's out the door. Vibant is the new era. All right, so we're going to park that for a second. I want to tee up a use case for the folks. So top right, there's a picture. Picture is a scooter that was used in an assassination attempt to kill a General Russian, Igor Kirillov, in Moscow in 2024. Now, this scooter was strategically placed outside his apartment building, and it was detonated once the general left for the office that morning, leaving the apartment, and it had effects on target. That mission was obviously planned around, and it was an assassination that was completed. Now, when we look at this, it begs a couple of questions. It's going to beg the question of how did the Ukrainian intel folks know where to place this scooter at this time? And we can surmise that Humint largely was involved with this. There was profiling, there was pattern of life that was taking place. But we can also attribute the massive effort of Ukrainian hacktivists that were just tearing apart Russian networks, releasing treasure troves of data out to the public to kind of pilfer through, find interesting nuggets, and work those into operational scenarios, operational intelligence. We actually will use some of these data sources for our talk today, and can show just how impactful this might be in this Vibant era. Now, the next question I want to pose is, imagine yourself as the decision maker that is giving this assassination order. They would want to have trust and confidence in the data that they're actioning, that the effects on target are going to be a probabilistic outcome, a confidence interval that's appropriate. And they're going to want to make sure that all those sources are vetted, and trust and confidence in those sources is applicable. So in the bottom right-hand corner, you could imagine that something was being prepared for this decision maker that looked like this table, that had top priority targets with their name, their locations, their phone numbers, maybe some additional context. And if we were to drill down into just one of those cells for that targeting package, you would have an address or a location that is probably derived of what we're showing right here, which would be like maybe 3 disparate data sets. And the magic that we're going to kind of talk through today is like when you glue these data sets together, interesting nuggets for targeting purposes, target-centric analysis will fall out of this. And one of the hurdles is right now is when a human intel analyst were to prepare this for you, you could imagine hovering over that address column, and you would get some contextual sourcing information list on the side if you're in some platform. You would know what the 3 sources were, how they were being, kind of stored, when they were accessed. But what they're not going to give you details into is what they did with that source, the transformations, the aggregations, the pivots necessarily. All that different context will not be there, and we're going to talk about why that matters in this era of Vibant. So inherently, there's a trust-based system that's being imposed on the people that are doing this work, aggregating this information, and disseminating it for action. And that trust-based is called data provenance. So data provenance now enters the chat. And what does data provenance look like in this trust-based system when we throw an agent in the loop? When we insert an agent in the process, we can't just necessarily transfer that trust to this new process. And to be fair, we're going to talk through the probabilistic nature of these, the non-deterministic outcomes. We don't necessarily want to just inherently trust the outcomes of these systems. I'm sure many have worked with ChatGPT or something else and been displeased with the output of the system, but pleased at other times. So to kind of just set the stage here real quick, agents are working on an autonomous spectrum. So they are giving access to largely a tool to interact with the world, and they're giving some amount of agency or autonomy to go about their task. It could be tightly coupled with very specific parameters. It could be human in the loop, or it could be, let's blow the lid off agency and give this thing freedom to roam. So that's one note about agents, is they are flexible and they are probabilistic. What do we mean by flexible? LLMs are using reasoning. Agents are using LLMs for reasoning and decision making. So that's the inference service being provided to us that's giving us an output. All right. So we've identified this issue that trust isn't necessarily inherent in these systems. There is a need for it. We might not necessarily have this context available to us when humans are doing this analysis work. So I'm a simple man. Simple solution might be to just simply jot down notes on your agent. This clicker, here we go, we got it. Okay, I'm going to put a description down. Agent with tool to find pivot in columns. Well, we're going to find very quickly as we start to pull this description apart, there are many ways to poke a bear. On the more deterministic side of this probabilistic scale, we have maybe using regexes for name checking or data field alignment to make sure the formats all pan out. The next more probabilistic approach would be to do maybe some value distributions or a course pivot with blocking keys. And then even the next step into the probabilistic domain would be to do an embed column for some vector permutation or checkup, and then maybe just completely chucking this column into an LLM system and seeing what nuggets fall out of it. So there's varying degrees within just that simple description of the potential transformations that could be taken by the agent. So this is too simple, and we need to do something more. Okay, let's take a little pivot off that and say, well, you're asking for like design decisions, Brad. So let me just like try and put a little bit more context around how I crafted and built this agent. So I did this agent to collate and merge data, and maybe I talk about maybe my design theory a little bit. But very quickly, we're going to run this issue of this cognitive-heavy versus tool-heavy agent problem. Unless you're providing the harness to me, which is the scaffolding that this agent runs in and kind of communicates with, I don't have transparency into whether you did this process at the bottom, where you just basically gave LLM a rudimentary CLI tool access call, and it had all the decision-making power in the world to kind of do something with, or you did this top left one, which is an LLM paired with multiple tools, all the tools, and it was maybe a little bit more tightly coupled. But even in this top left scenario, we have issues where I don't know if every single tool was called and compared for its output to find what is the highest scoring return. It just begs a lot of questions. All right, so I'm beating up on the agent process a little bit. I'm hopefully clearly identifying some of the hurdles that we're facing. And what we're really trying to get to is ensuring that this trust can be transferred through the system for when our partners, our decision makers come in and try to do some derivative work on top of what we've provided them for analysis. All right, so I'm going to splash up some eye candy. I'm going to put some wins in the column for agents. All right, what we have here is some nodes depicting all the columns of interest within our 3 data sets that we're using for this. So I kind of talked through previously in the scooter slide is 3 data sets were used to basically form this address column or this address field. In the center, we have the Yandex Eats leak, which was done in about 2022, providing locations of personal names, locations, handles. In the top left, we have the Get Contact leak, which was done in about 2024, which is a contact scraper that was put out there on the web for consumption. In the bottom right, we have known locations of GRU or FSB military base locations. So this was provided by the Institute. Martin, fact check me.
Institute for the Study of War.
Thank you.
Enhanced by us.
So known locations, and we can think through that. When present this information, automatically our analytical minds kind of get churning. We get excited. This is like syntactic sugar. You know, we're just like dopamine hit starts and like let's start pivoting through this data. But the beauty of an LLM, the win for the LLM with the agent, is the fact that you can take various analysis strategy pathways and explore them all with speed and scale. So one course of action that you could do is maybe going from the Yandex breaches, looking at interesting locations that might have a string in them, such as meet me at the front gate, meet me at this check-in point. That might allude to the fact that there's some security features, some physical security features at a base to kind of identify interesting locations. You go from known military base locations and kind of walk that path back to profiles and their other locations. And you could also go into the Get Contact info and look at strings such as Dimitri FSB, which is in there, believe it or not, and start to pivot off of just interesting strings that match kind of your higher level target-centric stuff. And you'll quickly kind of come to this aha moment where you realize that the probabilistic nature is a strength if you harness it correctly. And these LLMs will allow you to explore all these pathways where maybe in an analytical process, our bias is precluding us from looking at some of these different courses of action. All right, so you gave a win for the agents. let's talk about like what would this agent look like if it was producing those pivots. So in our most rudimentary design that Martin was kind of cracking away at here in the beginning part of the year, LLM was paired with an SSH tool, a Python tool that could do kernel calls, and then access to the Neo4j database, which is that previous image, to start to kind of map out this stuff at a high level. And the beautiful part about this is even with a rudimentary design, you can start to hit pay dirt. You can start to see success. You can start to get wins. The issue is just not consistently, right? You have to start to tightly couple this to get better performance out of it. And so in out of a trial run of 10, we might be hitting pay dirt 3 times. And an additional problem that we were finding throughout that process is you might not enumerate all of those different courses of action that I kind of laid out in each of these strategies. So the LM wasn't always on target. So I mentioned in the beginning I was an ops guy. And ops people want to just like tweak that engine, make it perform better, faster, stronger. They want to squeeze extra juice out of it. So Martin, I need a performance improvement plan for this thing.
You have one more slide.
Oh, of course we do. This is the shiny rocks that fell out of this, a little bit more motivation. Up in the top right, we have the FSB Special Operations Center. It's just slightly outside of Moscow in a suburb. And people tend to order food in there because it's just on a quick walk out the front gate to go get something. And one of the interesting nuggets, the little shiny rocks, kind of the dopamine hit that I was talking about, is that when Bellingcat looked at this data set, they found 20 good hits of orders to a known location. With the agent process, we were able to find 29, and that's due to that flexibility and probabilistic nature of the agent. And then the agent was then to do additional pivots off of that to find even further out into the suburbs of that surrounding area, additional interesting locations of where those mappings and those pivots could be correlated to other physical locations, such as single-family homes, apartment buildings, or hospitals. So definitely some interesting food for thought there. And then there is a great nugget of orders also being attributed into Kaliningrad, which I know Martin is going to continue to pull the thread on that one. So, all right, performance improvement plan. We want to make this better.
Yeah. Just to be sure, it's the agent that's going on the performance improvement plan, right?
We're going to talk afterwards, buddy.
OK. I mean, this was a very easy sort of pivot, where you basically have the addresses that are associated with a known military location, and you follow those out and look at those user accounts and are like, where else are they placing orders? And boom, you have some addresses that might be their private address. But the problem became the agent was not doing that consistently. So you sort of have to gather telemetry on what the agent is up to in order to distinguish good runs from bad runs. And then a very early indicator of a good run versus a bad run, what we call inflection points, was this military base right here, which is of the 147th General Staff Automobile Base just out of Moscow, which is associated with Unit 83466, which is in turn associated with supplying those missiles to the Ukrainian separatists that shot down that Malaysian Airlines flight. So great guys. And they really love to order food. Because the base is a little bit out of the way again. And so what became a very good scorer is sort of what is the reliability of finding those orders and pivoting off of them. And so what we realized very early on is that the agent was not carrying things out consistently because it was not managing itself. And so we introduced a self-management tool, the very rudimentary version of which was basically the agent traps itself in a loop. So it like discerns for itself, the LLM discerns that there are a number of items which need to be worked on, and then it traps itself in a loop to repeatedly execute its own instructions on that. So that ensures consistency and became an early scoring metric, and it massively improved the reliability problem, increasing the runs where we had the full scope of orders from 50 out of 100 to 96. How can we make it even better? Another inflection point became very high-level instructions. So for example, one high-level instruction that we used was find me Russian military bases that we don't have in our list. How might you go about doing that? Well, Brad already sort of teased it. You look for delivery instructions that have some military string in them, and then you discount those or you exclude those that already have a known military base for those coordinates within a 150-meter radius, or a larger radius, if you want even more certainty. And the thing with that was smaller models were really struggling with that. So something like GPT-4o was struggling, but not in the place where you'd think. You'd think, OK, GPT-4o is struggling to figure out the correct strategy to perform something like this, where it has to perform a series of pivots and data transformations in order to do that. But LLMs were actually really good at discerning that strategy in a reliable fashion. What happened a lot was, as they were trying to execute on that strategy, they'd hang themselves up, or they get lost in the weed. They'd produce something like malformed Neo4j queries. So our question was, how do we increase reliability of that? And the answer very quickly became, OK, what if we introduce something we call the Big Brother tool, which is basically a very advanced model, something like O3 or Claude Opus, which handles the strategic planning of an analysis strategy, and then passes it off to a smaller model that is much cheaper to run as needed in order to execute those analytical steps. What you see in the top is actually 2 runs to the left that did not have the strategy implemented, and 2 runs to the right that did have it implemented. So you can see it's a big jump. And then at the bottom, you can see the full outcome of that, which is Russian military bases that were not yet listed on our list for the Institute of Study of War. What we figured out later is that most of the stuff we found was buildings that had military protection, so usually associated with intelligence or sometimes the courts. So not necessarily military bases, but buildings under military protection. So basically, that's the point where we build smaller agents as tools. How can we improve performance even further? Well, one very valid criticism would be, well, you solved this in parallel. You have the answers already. And that's true. I mean, I did all the research, so we had a base against which to compare the agent performance. But that's not actually useful to you when you want to deploy it on data sets where you didn't do the full research. So what can you do? Well, the first thing, and there's some really interesting research that a colleague of mine at Dreadnode did on this, is you use an LLM to grade the work of another LLM. And I know that sounds weird. You're like, well, 2 fools don't make a wise man. And that's true. But if you think about the analytical steps that you need to take, and you sort of provide a high-level abstract framework against which we assess performance, then you can move through that step by step. And when you break it down step by step, the LLM grading actually aligns with human grading 85% of the time. That is the graph that you see here, where basically we're treating, in this case it was an offensive agent, where we're treating each step as its own distinct case. I'm running out of time to talk more about the graph, unfortunately. So we'll just say that you can align those human frameworks. And then again, scaling isn't necessarily a problem, it's the solution. So for example, if you're thinking about your reliability issues, well, what sort of reliability are you looking for? Do you care that the agent does the same thing every single time? Then you're going to have a determinism problem, because these are probabilistic systems. Or do you care about it getting a maximum result some percentage of the time? So this really is about like defining a good target metric. If you're also gathering the right telemetry for use cases in the wild where you don't have a labeled data set against which to compare it, what you're basically building is a great data set of workflows. And if you embed those, that's another comparison. So there's a lot of things you can do to improve performance, even when you don't have full visibility against what the desired result would be. So let's talk about the provenance of one piece of data, which is that Sergey at GRU really likes McDonald's. So Sergey's office is in the 152nd Preparation Center of the GRU, which is like 1 street over from the Russian Ministry of Defense. And this person is ordering from a McDonald's restaurant quite regularly, where it's just circled down there. It's like 2 blocks, not even. It's like 1 block from his office, and still he orders quite regularly. So Sergey is actually in the get contact data set, saved as Sergey GRU, and then saved a second time, which would give us his full last name. And we know it's this McDonald's restaurant because we could trace out the other orders delivered in the area. And what actually is really funny about his orders in particular is that our agent provided the information that he most likely eats his McDonald's cold. How do we know this? As part of the Yandex Eats dataset, you basically have an idea when was this food prepared versus when was it picked up by the delivery driver. So what you frequently see is that probably because it's a very short path, they don't get offered a lot of money to drive that distance. Also, when they bring it to the military base, usually maybe they have to wait around or something like that. So no delivery driver wants to pick it up, and it usually stands around for a good 10 to 15 minutes before it gets delivered to Sergey's office. So it just stands on the counter at the McDonald's. Then somebody picks it up, brings it over. And that's sort of what I want us to do, is to go through like cold case files and less necessary information. But again, this is an agentic output. And what we are hoping you will join us in is releasing information about the sort of agents that produce outputs like this in order to maintain our high trust community. So when we do release the agent and we do release the full reports, we're going to include a full reliability assessment that we're sort of teasing right here on what it does and how it works. And we'll hope you join us in building out telemetry when you're automating stuff like this and in releasing parts of that telemetry. Because I know that I trust you, but I don't necessarily trust an agent that your company employs to do some part of your analytical workflow. So just as some top-level information, at the top, the first one, 4%. So that's our variance. So or coefficient of variation, really. So out of a maximum of 9,000 top-level Intel pieces that the agent produced, that was the most productive run it had, usually our variance is around 300. So you come out to a 4% coefficient of variation. Then, for us, when we talk, yeah, I'm going to hurry up. We're almost done. When we talk about performance metrics, for us, it's only the one run that is most important. So we don't care as much about continuous deployment. So that's why there's only a 1, right? And then what we should be sharing really are agentic pathways that are taken to analyze information flowing through. So that's sort of what we're teasing here, which is 3 reasoning steps, 7 ingestion tool calls, 135 analysis tool calls, 2 presentation tool calls, and the sort of telemetry that goes with that. Because that gives you a lot of information about the system we built, including which related tool calls. Or even if you were to release that at top-level information, that is something that you can. So the point of this talk is we're all going to automate because we're drowning in data. But we're really hoping that as a community, we find some convention of background information to release on these automation systems as we do. Because when it comes to, analysis, trust is best. But for agents, telemetry is still king. Thank you.